For this lesson, we're going to be talking about matrices. Now, matrices is just an arrangement of numbers, and we put them in rows and columns. And when we talk about a matrices, the dimensions of the matrices tell me how many rows and how many columns are in the matrices, but you have to make sure it goes in that order. So we have rows first and then columns second. So for example, when we're looking at this matrix, this is the name. So matrix B has 1, 2, 3 rows and 2 columns. So it's a 3 by 2. All right, so when you talk about the dimensions, the first number is the row, the second number is the column. Remember, rows go horizontally and columns go vertically. Okay. Now, there's a few more notations that we're going to talk about. So if you have a matrix, like I said, it's shown by a capital letter. Could be A or B. It really could be anything. And each entry, or we call it an element, is shown by a lowercase letter and has a subscript of the row and column. So if I'm looking at and I say I want to find A of 11, that's row 1. A11 is going to be row 1 and column 1. Okay? Or if I have A12, that's going to be row 1, column 2. So the other thing that you've got to remember is when we're looking at our notation is if you remember the word arc. So if you remember the word arc, that tells you A is the element, R is the row, and C is the column. So for example, if I tell you what is the element A 21, so A21 or A21 is going to be row 2. So we're going to be looking at row 2, column 1. So that's going to be 23. Or if I ask you to find A22, that's going to be row 2 and column 2. That's going to give me 12. All right, so first number represents the row, second number represents the column. Now, the next thing that we're going to talk about is actually looking at adding and subtracting matrices. Now, in order for adding and subtracting matrices to work, they have to have the same dimensions. So you can't add a 2 by 2 by a 2 by 3. Okay, so for adding and subtracting, they have to have the same dimensions. If they're not the same dimensions, then you cannot do it. It's undefined. Okay, so every dimension, when we do adding or subtracting, has to be the same. And then when we are actually doing our adding and subtracting, you do it based off the corresponding row and column. So when I'm looking at my example here, you can see this is row 1, column 1. So we're going to add that to row 1, column 1 of the second matrices. And that's going to give us 7, which gives us our new element. So then here we have 8 plus 0 gives me 8. Then we have 4 plus 1, that gives me 5. And then we have the last element, which is in row 2, column 2, that's 6 plus -9 gives me -3. Same thing with subtraction. Using the same matrices, you always use the corresponding spot, the corresponding element. So this is going to be 3 minus 4 gives me -1. 8 minus 0 gives me 8. 4 minus 1 gives me 3. And then finally, 6 minus -9 gives me that 15. So let's do a few examples. So for this example, it's asking me to do A minus B, or excuse me, B minus A. So we've got to make sure that we do it in the correct order. So I'm going to be subtracting the B matrices and the A matrices. If you did not subtract it in the correct order, then of course that's going to give you the wrong answers because you would be subtracting backwards. All right, so we're going to start with 0 minus 3. So 0 minus 3. So I'm going to write my new matrices as I'm subtracting. So 0 minus 3 gives me 3. Then I have 5 minus negative 3. So 5 minus negative 3, that's going to be 5 plus 3, which is going to be 8. Then I have 4 minus negative 5. So that's going to be 4 plus 5, which is going to give me 9. And then I have 1 minus negative 4, which is going to be 1 plus 4, which is 5. And then I'm going to continue this process. So I have negative 3 minus negative 1. So negative 3 minus negative 1 is going to be negative 3 plus, negative 3 minus negative 4. So negative 3 plus 4 is going to give me positive 1. Then I have negative 5 minus 3. So negative 5 minus 3 is going to give me negative 8. And then 3 minus 1 is 2. And 2 minus 3 is negative 1. And there is my subtraction for that matrices. All right, so for the next one, we're going to add these. Now, I'm not going to rewrite them because it's already in the order that we want. So we're going to add these two together. And I can add these together and just make sure, again, this worked out because this was a 4 by 2. This was also a 4 by 2. So we could add those because they had the same dimensions. So this one is a 3 by 2. This one is also a 3 by 2, so it works. All right, so we're going to add negative 2 and negative 5, which is going to give me negative 7. Then we're going to add negative 3 and 4. That's going to give me positive 1. And then we're going to continue with each element. So 4 plus negative 4 is 0. Then we have 0 plus negative 5 is negative 5. Negative 3 plus negative 5 is going to give me negative 8. And then we have negative 3 and negative 5 again is also going to give me negative 8. Okay, so pretty simple when it comes to adding and subtracting. The key is they have to have the same dimensions, and you have to make sure when you set it up that the matrices are in the correct order of what they're asking for. All right, so then the next thing that we're going to talk about is multiplying by a constant. So this is actually called a scalar. So when you were in Math 2, I believe, and you were doing transformations and you talked about something, scaling on the coordinate plane, if you multiplied it by a number, it got bigger as far as being greater than 1. If you multiplied it by a number that was less than 1, then it got smaller. So when a scalar is basically taking the number that you're multiplying by, and you're going to multiply it into the matrices. All right, so if we look at this example, so 2 times this matrices. So 2 times this whole thing, we're going to do it for each individual piece. So 2 times 4 gives me 8. 2 times 0 gives me 0. 2 times 1 gives me 2. And then 2 times negative 9 gives me negative 18. Now, again, basic multiplication is just basically like distributing. You're distributing the 2 to the entire matrix. So I'm going to step it up just a little bit, and I'm going to do a combination of some subtraction and some scalars. So this is saying that we're going to multiply, This is saying that we're going to multiply 6 to the A matrix, and we're going to do 1/5 times the B matrix, and then we're going to subtract the 2. So we're going to do them individually. So let's do the 6 times A. So 6 times, so we have 0, 1, 0, negative 1, and 3. So this is going to turn into 6 times 1 is 6. Then we have 6 times 0 is 0. 6 times negative 1 is negative 6. And then 6 times 3 is 18. So there's our first matrix. Then we're going to do 1/5 times B. So for 1/5 times B, we're going to take and we're going to multiply it into that whole, every element in the matrix. All right, so we have 1/5 times 1, or negative 20, that's going to give me negative 4. 1/5 times 15 is going to give me 3. All right, so 1/5 times 35 is going to give me 7. And then 1/5 times 60 is going to give me 12. Now, at this point, we've got our two matrices, but now we need to subtract the two. So we're going to make a whole new one. And again, this would have to match dimensions, which it does. This is a 2 by 2, and this one is a 2 by 2. So we're going to do 6 minus negative 4, which is going to be 6 plus 4, which is 10. Then we have 0 minus 3. That's going to give me negative 3. Then we have negative 6 minus 7. So that's going to give me negative 13. And then finally we have 18 minus 12, which is going to give me 6. So my final matrices is the one in which we did the subtraction. So we need to do it in steps. We need to do our scalar multiplication first, and then after you do the scalar multiplication, then you can do your adding or subtracting from there. We will continue with matrices, but for this lesson, we're going to stop here.